we are going to talk about Euclid's division lemma. But let's first talk about what exactly is the meaning of this word lemma, all right? So lemma is a proposition or a statement which has already been proven in mathematics, and it can be used to prove other things or other theorems. So Euclid developed a very simple statement that is used in division of two numbers. So our objective in this tutorial is twofold. One is that we want to understand what exactly is Euclid's division lemma, and the second is how exactly is it useful to us, okay? So to explain this in a very simple and effective way, let's say we have two numbers, two integers, 43 divided by 8, okay? In your simple elementary level long division method, you will say that 8 times 5 is 40. That leaves a remainder of 3, correct? So this is your quotient, this is your remainder, here is your dividend, and you have your divisor 8, right? If you were to make a relation between 43 and 8, you will say that, well, 43, the dividend, it could be written as 8 times 5 plus 3, right? Now take it one step further. Instead of keeping these numbers as the hard numbers, what if I replace them with a general number? So 43 becomes a, for example, and a could be any number, any integer, positive of course, and we say that b is 8, okay? We replace 5 with q and we replace 3 with r, okay? Then you will say that I could define the relation between these four integers as a is equal to b times q plus r. So this one simple expression, it basically replaces this long division, that how do you define a relation between a dividend, a divisor, a quotient, and a remainder. So Euclid's lemma is simple mathematical statement that defines a relation between the dividend, divisor, and so on. And it states that for each pair of positive integers a and b, there exist two whole numbers q and r, right? That satisfies this relation, that a is equal to b times q plus r, where the condition is that the number r, the remainder, it has to be greater than or equal to 0 and less than b. Of course, you understand that remainder is always going to be less than the divisor, correct? And the numbers q and r could also be 0. This is what is known as Euclid's lemma. Now, I would like you to pay some attention on the keywords here. We are stating that for each pair of positive integers, which is important here, okay? And we are talking about two numbers a and b, that a is always bigger than b. Only then you could define a relation, something like this. So this is Euclid's division lemma. As complicated or as fancy you may want it to make, but in reality, it is only defining a relation between a dividend, a divisor, a quotient, and a remainder. Okay, these four numbers. So let us take a look at some examples to utilize Euclid's division lemma to find the HCF of two numbers. We have two numbers, 36 and 24. Let's say this is A and this is B. Whichever is the bigger number of these two will be the A, right? And then we are going to convert those numbers into this standard form where a is equal to b times q plus r, right? Now we can say that our step 1 is this, 36, which is a, can be divided with 24, which is b, and then you have your quotient to be 1, and then you have your remainder to be 12. So at this stage, we are going to focus on two numbers only. The one which is the divisor, which is b here, and then one we have the remainder, okay? In this case, we notice that r is equal to 12, meaning r is not equal to 0, correct? In that case, we need to take the second step, in which what we have is this divisor, what we have 24, that becomes your new dividend, all right? And this remainder, if it is not equal to 0, we need to make that as your new divisor, right? So 24 will be divided with 12, and you will say that it is equal to 12 times 2 plus 0, right? Now you have a remainder. That remainder is equal to 0. And that's exactly where we need to stop, because now we have come to a new point where we find this divisor, which is b in this case, is 12, and HCF of 36 and 24 is your most recent divisor in the step in which you find your remainder to be 0, right? So this is your HCF. Very simple, right? Let's take a look at one more example to revisit this method. So my second example is find the HCF of 44 and 14. 44 is bigger number. I'll make that A, this is B. So we will say that 44 is a product of 14 times 3, right, plus 2, where this is my step 1, this is your divisor B, and this is your remainder. Since remainder is not equal to 0, what I'll do is I'll convert this divisor 14 into new dividend, and 14 will be divided with this remainder, the one which is 2 here, right? So 14 will be written as 2 times 7, and you have your remainder 0, right? So R is 0 in this case. All right. So once again, you have reached a point in your second step in which the remainder is 0, and you have your new divisor, the one which is B, is equal to 2. So as simple as that. The moment you find a step in which the remainder is 0, you will say that your HCF of your original numbers 44 and 14 will be the divisor at a step in which remainder is 0. So that will be 2, right? Once again, very simple, correct? Let's take a look at one more example. So in our third example, we have two numbers, 25 and 3. We need to find the HCF. 25 is bigger. We will label this as A. The 3 is smaller. It becomes B. So we will divide 25 with 3. We will say that this is my dividend. 3 times 8 is my one product, and then you get your remainder as 1, right? So let's label it accurately. So this is your A, this is your B, you have your quotient, and you have your remainder. So in this step, remainder is not equal to 0. This is my step 1. That means we need to go to step 2, in which this divisor, the one which was here in step 1, becomes your new dividend, right? So 3 will be written as a product of, in which the remainder from the previous step becomes your new divisor. So 3 is to be divided with 1, and that will be simply written as 3 is equal to 1 times 3 plus 0, right? Simple enough. In this case, you have reached a point in which the remainder is 0, right? That simply means that you will focus at your new divisor, which is 1, because at this stage, you have reached a point in which remainder is 0. So this is your HCF. Or in other words, HCF of 25 and 3 is equal to 1. That means the only common factor between these two numbers is 1. Simple enough, right? Just to give you an idea. The other method is you will basically explode these numbers into their prime factors, right? And then find which one are the common factors, right? And that will be your highest common factor. So these are some simple techniques to find the HCF of two numbers using Euclid's division lemma. So the purpose in this tutorial was to explain what exactly is this lemma and how do you use it for various applications. In our next tutorial, we will go learn a little bit more about the real numbers.